All right, so in this video, I'm going to be looking at solving equations again. These ones are going to require 2 steps, however, to undo our operations and isolate x, or get x, our variable, all by itself. So when I'm looking at something like this, I always want to start reading my equation on the left-hand side here. So if I was to read this out loud, this says 4 times x plus 5 will equal 29. Okay, so 4 times x plus 5 is equal to 29. Now, the reason I want to think of it like that is the first thing that is happening to x is it's getting multiplied by 4. So if I pick some value for x, the first thing I have to do is multiply it by 4. And then afterwards, I would add 5 to whatever this sum or this product ended up being. So I'm multiplying first and adding second. And it's important to know that because what we're going to be doing is undoing all of these steps, but in backwards order. So if what I would do first is multiply x by 4 and then add 5 after, in order to undo that and go backwards, I need to get rid of this plus 5 first. So I would need to subtract 5 first, because that is how I would undo adding 5, right? If somebody puts a $5 bill in your hand and then somebody else takes that $5 bill out of your hand, you've gone back to whatever amount of money you started with. Right? So if we add 5 and then subtract 5 immediately after, it's like nothing has happened. Now remember, whatever I do on one side of the equal sign, I have to do on both sides. We have to treat both sides of an equation equally. So once I do that, the 5's are now canceling one another, and I'm left with 4x is equal to, on the other side, 29 minus 5 is 24. And so now this says 4 times x is equal to 24, and so the opposite of multiplying x by 4 would be to divide x by 4. And again, what I do on one side, I must do to the other. That cancels out my 4's on the left-hand side, and now we have x is equal to 6. Okay, that would be our answer. So what we're going to look at doing is we're going to solve and verify these equations. So if I had something like 3x minus 5 is equal to 22, what I'm going to do is I'm going to take x, multiply it by 3, and then I subtract 5 after. So if I want to undo this process to figure out what x is, I'm going to start by adding 5 on both sides, because the opposite of subtracting 5 is adding 5. That's going to cancel those two 5's, and now I'm left with 3x is equal to 22 plus 5 would give me 27. And now I have 3 times x is equal to 27. So the missing number x, the way I'm going to get there, it's being multiplied by 3. The opposite of multiplying by 3 is dividing by 3. So I'm going to divide by 3 on both sides, and I get x is equal to 9. So I do want to double check and make sure that 9 is the correct answer. So what I do, remember, I'm going to verify by setting up my left side, right side chart. And I want to write the left-hand side as it started in my original equation before I started messing around with it. On the left-hand side, I had 3x minus 5. On the right-hand side of the equal sign, before I started messing up with it, I have 22. Okay? And what I'm going to try to show is that if I change x to a value of 9, do I get 22 on the left side and the right-hand side? That's what we're trying to prove. So I'm going to start off by saying I have 3, and then I'm going to change x to be 9. And remember, when you substitute into your expression, make sure you put that value in brackets. So I have 3 times 9 minus 5. So order of operations tells me that I must multiply before I subtract. Okay, so I'm going to do that multiplication first. 3 times 9 gives me 27. And then 27 minus 5 is 22. And that's great because it means I got the same thing on both sides. Okay, I want to show each side separately and show that they give the same thing. Okay, if I was to do this one, 7x plus 12 is equal to negative 16. So again, I'm going to start off by saying x is being multiplied by 7, and then that product is getting 12 added to it. To undo that, to walk through it backwards, I have to start at the end and get rid of that first. So if I multiply x by 7 and then add 12 to go backwards, I have to take 12 away as my starting point. So I'm going to subtract 12. And I'm going to subtract 12 on both sides of the equal sign. Remember, we want to treat left and right equally. So now I have 7x left over, because positive 12 and negative 12, they cancel one another and make a 0 pair. So 7x is equal to, on the other side, negative 16 minus 12. So negative 16, and then I take away 12 more, gives me negative 28. Now I have 7 times x is equal to negative 28. The opposite of multiplying x by 7 is dividing x by 7. So that's what I'm going to do on both sides. My 7s on the left are going to cancel. And the only thing I have left now on the left-hand side is x, which is good. I wanted x all by itself. On the other side, negative divided by positive, because there's no sign written there, so it is positive. Negative divided by positive is negative, and 28 divided by 7 is 4. Now I want to make sure that negative 4 is the correct answer, so I'm going to start back and look at my original equation before I started doing anything to it. So I started off with 7x plus 12 on the left-hand side, and on the right-hand side, I started off with negative 16. Now I'm going to change x to its value we found, and we said x should be negative 4, so I'm going to change x to be negative 4. Remember, when I substitute it in, I make sure that I put it into a set of brackets. Because it's in that set of brackets, this 7 being written directly next to my set of brackets means these are multiplying. But I don't want to write x for multiplying because x is my variable. So that's why I'm using the brackets instead. 7 times negative 4 gives me negative 28. Negative 28 plus 12, I know that I have a larger group of negatives, so I will have negatives left over. 12 of those negatives are going to get canceled out by my 12 positives. That means I will have 16 negatives left over. And we get negative 16 on both sides. Okay? If you want to, try pausing the video really quickly and work through this one yourself, and then double check your answer. With this one, first thing I'm going to do is I'm going to get rid of that negative 9 by adding 9 onto both sides. And really what I'm doing is I'm getting rid of the constant. I'm getting rid of the number that is not attached to the variable first. So I'm getting rid of the constant on both sides. So I add 9 to both sides, and that gives me negative 2x is equal to 24. I'm then going to divide both sides by negative 2. So I have that negative in front. I want to get rid of that all at once. So I'm going to get rid of the negative 2 by simply dividing by the whole coefficient, negative 2. The negative 2's on the left are going to cancel, and the only thing left over now is x. Positive 24 divided by negative 2, opposite signs, so negative answer. And 24 cut in half is 12. Let's make sure we have the right thing. Okay, our left-hand side started as negative 2x minus 9. The right-hand side started as 15. I'm going to write that negative 2 again, but instead of writing x, we said x should be negative 12. Let's switch x to negative 12 and see if we're right. Okay, I need to multiply before I subtract. So negative 2 multiplied by negative 12, negative times negative is positive. 2 times 12 is 24. Positive 24, subtract 9, gives me 15. And that's great because now I have 15 on the left side and the right side. They end up being the same thing, which is good because the equals sign told us they had to be the same thing. Last one. Negative 8x minus 31 is equal to negative 47. So the first thing I'm going to do is get rid of this constant. I'm going to get rid of that subtraction. The opposite of taking 31 away is adding 31 in. The 31s on the left cancel. On the left-hand side, I now have negative 8x is equal to, on the other side, negative 47 plus 31 gives me a value of negative 16. Then I'm going to divide both sides by negative 8. My negative 8's on the left will cancel, and I've got x is equal to negative divided by negative is positive, and 16 divided by 8 is 2. That means if I put 2 in for my x into this expression here, negative 8x minus 31, if I put in a value of 2 for x, I should get negative 47. That's what my answer should be, so that's what we're testing. I'm going to change x from being x to making it positive 2. Now I'm not going to put in the positive sign. If something's positive, I can just leave it with no sign in front and we know it's positive. I need to multiply negative 8 times positive 2. Negative times positive is negative. 8 times 2 is 16. If I have negative 16 and then I subtract 31 more, or if I have negative 16 and then I have 31 more negatives, I move down to negative 47. Okay? And that's great because I now have the same value on both sides. So when you're solving two-step equations, we want to get rid of the constant first. The constant is that number that is not attached to the variable. When you get rid of the constant, notice the number stays the same, but I just have the opposite sign. Second, I am going to get rid of what we call the coefficient of x. In this case, it was negative 8. But because the coefficient multiplies our variable, the way I get rid of it is dividing by the coefficient. So I take that same number with the same sign, and I divide both sides by that value. Okay? Remember, whatever you do on one side, you must do the same thing to the other side. The equal sign says we have to treat both sides equally. And that's solving two-step equations.